So that's just a line, right?
Yeah.
And so what we can do is I can show you the work, or you could kind of do the work on your own now, right? Is here are our inputs, right? Remember discussing that?
Yeah.
And y's are going to be our outputs. Okay, and this little column in the middle is just for you to do the work. Okay, so it's like a good habit. So what I want you to do is to like plug in -1 into the line, right? So you're going to get 2 times -1 plus 1. You know what I mean?
Yeah, because your input is the x, which is 2x,
Perfect.
so you put it in brackets there.
Perfect. So I know that seems like redundant, but literally the work that you're going to do down here for this question, obviously that doesn't look the same now.
No.
But the work is going to be identical. So it's good that you're able to, you just plug it in. And then you get a bunch of points, and then you're able to like graph it, right? And then so these little things on the side, these extra little, these things over here,
yeah,
this is how you tell the difference between the two, like to mathematically prove that they're different. Okay, and I'll show you how to do that.
So you put the x in the left?
Yeah, so we'll do that first. We'll get a whole bunch of y's, okay, like outputs. We'll get a whole bunch of outputs for both of these. We'll do the first one first. But 2 times -1 is going to be -2, right? Plus 1 should equal -1, right? So it's -1. And then we can do it again. 2 times 0, that shouldn't be a negative there. Just 0.
0.
0 plus 1.
1. So it's positive 1.
Okay. 2 times 1
is 2. So 3.
Okay.
And that's 5.
Yeah, so, okay. So good.
It goes up by 2.
It's going up by 2. That's good.
7.
Okay. So this is where we arrive at the stage of like proving that this is a line, okay? And we do that. Do you remember seeing first and second differences? You ever seen this?
I wasn't very good with these.
Okay.
I don't think.
So this is like pretty straightforward. It just needs to be, like, I think this is a pretty good layout for doing what you think you need, or just for doing this. Okay, so this column here, the first one, is going to be first differences. Okay, and you're doing literally first differences, like literally do the words, right? And then the second one is obviously going to be your second, right?
Yeah.
So what it means by difference is you're going to do, and it doesn't matter which direction you go from. Okay, what you're going to do is you're going to go, I always start from the bottom, but you can do it either way, okay? I go 7 minus 5. That's what goes in this box. What is that? 7 minus 5.
Oh, I remember doing this thing. You do 7 minus 5, then 5 minus 3, and
yeah.
3 minus 1.
You do exactly the little, like, the alligator mouths or whatever, right? So you're doing 7 minus 5, which should be?
2.
Okay.
Yeah, there should be 2.
5 minus 3 is 2.
Yeah.
Good.
And then
3 minus 1. 1 minus -1.
Oh, would that be -2?
So let's do it. 1 minus -1. That's what it means. So 2 negatives turn into
positive. So
it's 1 plus 1.
So 2. I didn't know if they'd throw a curveball and be like, oh, well, this one isn't the same. Like,
no, they won't do that.
Okay.
No, not for your purposes.
Alrighty.
Once you see a few of them that are the same, like it's kind of, I don't know. If you get 2 or 3 of them, chances are the rest of them are going to be the same. Just because it's hard. If you get some of the differences to match up to be the same, it's hard to make this one not match.
Yeah.
You know what I mean? The 4th one or the 5th one or the 6th one, anyone after that, it's hard to get them to not match. So this is important, okay? Because this, what we'll write down here is like, because these were the first differences, right?
Which is on the left, yeah.
So all these guys. And remember what we're doing. We're finding the first differences or the differences between the output values.
Yes. And also, how do you find, like, or what? How do you know whether it's subtraction or something? Or is it always going to be subtraction?
It's always going to be subtraction because it's first differences.
Okay. I just don't know. Maybe there's different things.
I don't think you'd ever add them.
I didn't think so, but
You could just get, that's what I was saying, like you get to use exactly the wording for differences, which is kind of nice, right? You can't mess that up now because it's just differences, subtract. So what I'm saying here at the bottom, you're able to draw a conclusion from this. Okay, and it's an important one. So because, that was relatively easy, right?
Yeah.
Okay, so because the first differences are the same, it's a line. Right? We can confirm that that's a line, right? We know that.
Because the y are all... Because those are the y, the first...
Yeah, because all the outputs increased by 2, increased by 2, increased. That's a line. Increased by 2, increased by 2,
It goes
by 2.
on.
Yeah. Forever, right? But it's always just going to go on forever in an up 2 over 1, up 2 over 1, up 2 over 1, right? So that's, but that produces, this is your way of actually mathematically checking that that is true. Okay. Does that make sense?
Yes.
So the first difference piece. Okay. Now, obviously this one, this equation in number 2 doesn't look like number 1.
Not at all.
Right. So like, as you go through this is actually the first question is determine if this relationship represented below are linear or quadratic. That's in my practice exam. So you'll be like, oh, here's the representation. That looks a lot like what we just finished. Now you could say, is it a line or is it a quadratic? I know we haven't done quadratic stuff yet, but you could say, oh, this one's a line for this reason. You could do the first differences are going to be the same, right? That's why, because of these first differences. Now, the reason why there's 2 boxes is because if these didn't match, then I could do it again.
And then if they end up matching in that second one, then it's still a line?
Then it's a quadratic.
Oh, okay.
Okay, so that's what I'm saying. As soon as they match, that's it, you stop. But you need to make a determination at that point whether, how many of them have you done. If you've done 1, then it's a line. If you've done 2, then it's a quadratic, as we'll see here in a sec, okay? So I want you to do the exact same thing here in the second one that you did in the first one, except the work is a little longer because the equation looks a little bit more complicated. That's literally the only thing that's changed.
But you still plug in the same values.
You plug in the values that they tell you to plug in right here.
So, yeah, we do y equals -2.
Okay.
Like in brackets, so with the exponent outside of the brackets.
Okay.
And plus -2 plus 1. Now, if you have an exponent with a negative, will that be a positive?
Yep.
Or, yeah.
Because what's it actually mean? Do you know what the exponents actually mean?
That times that. So yeah,
twice.
So that cancels it negative.
Yeah.
It's positive.
Yeah.
Okay.
What if I gave you this?
Would it be the same because it cancels out?
But what rewritten, it looks like this.
So it'd be negative.
2 of the negatives cancel,
but there's
still a third one. So then you go 2 times 2 is 4 times 2 is 8 with a negative.
So whenever you have, like, say there's like a -4 inside of brackets with like a 4 on it, like outside the brackets for an exponent,
that's different.
Then it goes to a positive. But other than that, it's negative.
Yes.
Okay.
So if you have that, that's when a lot of people make that mistake, right? Because they'll type. What you have to be careful of when you type this in your calculator, and you might end up doing this as this get a little more complicated, right? Is everybody wants to go to their calculator and go like this. And that's what they write down. But why is it doing that? Because what it's doing is it's treating, when you type it in that way, it's treating it like this.
So the negative isn't.
The negative's just floating. It hasn't even done anything.
So it doesn't affect it at all. It just
not when you type it like that.
Yeah.
But if you were to go to your calculator, you have to type. Either you just know that 2 negatives, like when you square a negative or you multiply 2 negatives together, it becomes positive. Or you actually have to type it in your calculator like this.
With brackets.
With brackets. Because then it's the way it works. Anytime an exponent is on a bracket, it gets applied to both things. So
it's just like what you showed me last week with the, like where you go from... The distribution
yeah.
stuff.
We're going to do that today.
Yeah.
We're going to do that today on like page 5 or whatever it is, page 4. Okay, does that make sense?
Yes.
So it's honestly the exact same thing as the one above, but it tells you something different. Okay, and it tells you something different because the question, like the equation's different. Okay, so for you to do this, you might get the hang of it and do it in your head, right? Because most of the time you're just going to have 2's. You're not going to have like 9 squared plus 9 minus or plus 1. Like it's going to be a simple question, right? So you're going to be able to go, okay, well, negative 2 squared should be 4, and then minus 2 plus 1. That's the work on that, right?
So
I just did the math on each piece individually.
It'd be 3 then. That'd be the
4, yeah. So 3 goes in the y. Okay, and then you're like, okay, I'm good with that. We'll get rid of it, and then we can do the next one. Okay.
I also get confused when it says plus negative 2. That confuses me because it's like I don't know what to do there. Whether you subtract it or if you.
So that's like, remember the rule we could do? We could always just kind of always add a 1, an imaginary 1, basically wherever we want. What's plus 1 multiplied by negative 2?
It's negative 2. So that plus just acts like a 1 then if you have it beside. Okay.
So the negative always dominates because it's the thing that throws the wrench in things, right? So it's going to, like, if you see a positive and a negative, the negative's just going to take its place. Okay, does that make sense?
Yes.
So that's like the raw reasoning. You don't need to show that. You could just, as soon as I see that, I know it's minus 2. You could basically scratch that out.
All right.
Okay. Okay, that's a good point too. These are all like valid concerns that come up all the time with all sorts of kids.
And that's
right?
where
like,
I went wrong a lot of times. Yeah. It's just silly mistakes that throw your whole question.
No, absolutely. That would change. If you did plus 2 there, you'd have 4 plus 2 plus 1 would be 7.
It's just
it's not
way out of there.
Right?
Yeah. So
that's good. Like that happens all the time. So you're not alone in that.
All right.
Okay, so let's do the next one is going to be negative 1 squared plus negative 1. I'm going to continue to write it like that, so let's see if I can catch you. All right. So negative 1 squared is going to be
1, yeah.
And
plus, then minus 1.
Good.
Plus 1.
So that's a wash.
So it's just plus 1.
It's 1. Good. So you will develop the ability to, like I've done this lots and lots and lots of times, right? So I can do these pretty much in my head. Something interesting going to happen here.
Would it be 0 minus 1 plus 1?
Yeah, something interesting is happening here, though. I think I had this issue last time I did this, too. Let's see what happens. I don't know. So if we plug in 0, okay. This isn't supposed to do this, I don't think.
It'd be just 1, really, because you can't do negative on 0.
Yeah. Okay, and then the next one? Oh, we're okay. Never mind. I'm getting ahead of myself. We're fine. Right. You'll see. So what I'm doing, I'm like, I've done this already, and I'm like already thinking this isn't going to work, right? But it's going to be fine. Okay. So let's do the next one. 1.
It'd just be 1 plus, 1 plus 1.
So it's 3.
3.
Okay, and then let's do 2. So it's 2 squared plus 2 plus 1.
So it'd be 4 plus 2 plus 1.
Is?
Yeah. What would it be?
4 plus 2 plus 1.
So that's, why can't it? 7.
That's it. Okay.
That's a pretty big difference.
Yeah.
From 3 to 7.
Okay, so good. Now, I want to do the exact same thing we just finished doing. Okay, let's check the first differences and see what happens.
So that'd be 4 in the first box. Oh, yeah, you have to do that.
Nope, yeah, that's fine. You don't have to, but you just know. So 7 minus 3 is?
4.
Okay. 3 minus 1?
Is 2.
1 minus 1?
Is that 0?
Yes.
Yeah. Just
1 minus 3.
Negative 2.
Yeah. Okay, so those don't match.
No.
Okay, and so what conclusion can you draw from the fact that that is not matching?
It's not a line.
It's not a line. That's good. Okay, but here comes the cool part. What if I did it again?
Chances are, well, they're all going to be the same then because it's all 2.
4 minus 2.
It's 2.
2 minus 0.
2. And then 2. Ah, yeah, that's 2.
Well, okay, it is 2 because you'd go 0 minus negative 2.
Yeah.
Now, those match. Which
the
means
first differences don't.
The first ones don't. So that's their test, right? That's what we're doing. First ones don't match, but the second ones do.
And the second ones mean it's a quadratic.
Yes. So because the second differences match, it's a quadratic. You'll spend, honestly, like you're going to redo this course, and who cares what you got the first time? Like it doesn't matter, right?
Just go in at fresh start.
You go in fresh start, and like now you have like, between what we've done now, you have a really, really good start. Like those classes move at a pace that's appropriate for, this is in the applied stream, they move at a pace more appropriate to like the weakest student in the class. You know what I mean? Whereas I think some of the academic is kind of the middle, and then they try to pull everybody along for both sides, right?
Yeah.
Like the kids at the high end are just going to be the kids at the high end, right?
Yeah, there's no change in that.
But so there's always like the applied stream, I think we try to cater towards the kind of lower end and build them up. So you'll find that those move at a little bit of a slower pace than the academic classes might move, right? So I think in doing this, like, it's all about repetition and the amount of like how much you've submerged yourself in the material, right? So I think you'll have a better grasp at it the second time around.
I think so.
Right?
Because I really don't want to fail it again.
You'll probably be fine, right? Like just in doing this and like talking and like, I think you got to like, you definitely at least have the potential to like figure it out. You'll be fine, right? It's just I don't know who taught you the first time. Like there's all sorts of different factors, whether or not you resonate with that person, how much work did you put in. Like there's infinite number of factors, right?
There's some issues with my teacher, okay. So that's probably half of it.
That might be half of it, right? But it is what it is, right? Sometimes you gotta like bite the bullet. Like I didn't necessarily like all my teachers in high school, and I definitely didn't like all my profs at university, right? But you kind of like
rolled the punches.
Yeah, you roll the punches. You kind of like, you might not do as well as you might hope, right? But you still gotta kind of take responsibility for it. You know what I'm saying?
Yeah. Oh, I take full responsibility.
Absolutely.
I shouldn't have got.
Absolutely.
I don't know if you know the grade I got, but it was really.
No,
bad.
I don't. It doesn't matter.
It was terrible.
It doesn't matter, right? What matters is that like I think you're gonna do better the second time.
Yes. No, right? I'm pretty confident. Like just knowing that like. I find I do a lot better with sit down like this instead of being in the classroom because I get all worked up in the classroom.
Yeah.
And so does a lot of people. I feel like I can get this more because I don't feel like I have the pressure of somebody asking me in front of 20 kids. And
I think that's kind of like some of what I do here with the videos and whatnot. That's like for kids like yourself that can just like, okay, I didn't get it in class today, but I can go home and sit and watch it again by myself.
Figure it out.
Yeah. That's why I do it. And like maybe you're sick one day. Then there's zero like it. Not that I'm trying to like get rid of the responsibility of me being the teacher and you being the student, right? Like, but like I've done my job. You know what I mean? I don't have to chase you to get you caught up on anything and then have that come back on me. Like everybody knows where everything is. You go and watch it, and when you miss a day, right? Yeah, it's all right there in black and white. So try to like, I try to give you the best opportunity to do the best job that you can. You know what I mean? So anyway, does that make sense?
Yes.
That's like kind of a long-winded whatever. We're giving life talks too, but
yeah.
As long as you understand the fact that like that's how you prove. That's a big chunk of the test. Like that was, I'd say that was one of the first pages in my exam. Right? Like, and typically most of the time, like we're supposed to as teachers, right? Like. If you were to like get 100% on the exam and you failed the entire semester, like your mark is supposed to be representative of your most recent performance. You know what I'm saying? So who cares what happens through the course of the semester? You get to the exam, like, and you absolutely nail the exam. That's gonna have a heavier weight on the fact that like
you don't like fail the class.
The semester didn't go well, right? So anyway, usually 4 marks. That's the first page. Determine the relationship. Is it linear or quadratic? And then tell me why. Right?
We
4
just did
marks.
that.
That's what I mean. Plus, if we keep going through here, slope of a line, y-intercept. Passes through the point this and this. 8 marks for just graphing a line. Well, 4 for that one, and then
4 for that one.
4 for this one. We already did that.
Yeah.
Right? It looks like, by the look on your face, it looks like you know what you're talking about, right? Because we did that. This we haven't done. We're gonna do this stuff. Does that make sense?
Yeah.
We're just gonna keep chipping away at stuff. It's gonna be fine. You know what I mean?
Because most of it is just graphing.
Graphing and
That's what I noticed when I did my exam. It's most of it's like asking, like throwing different equations in to see if you can get them.
Yeah, so that's what we're gonna do next. Actually, we're gonna look at a graph. Okay, and so this we're done. We're kind of done with lines. Okay, this was my way of connecting you between lines and quadratics. Okay, so you can see the difference. You can tell. You can explain now. The other thing you can look at is if there's a square there, it's a quadratic. If it's a 1 on the x, it's a line, right? But that's not going to be enough to like give you full marks. I would say you can talk about the first differences, or you can talk about the fact that you're always increasing by 2 for a line, right? Yeah. Whereas a quadratic, its differences are changing. So the graph is not a line anymore. It looks something like this. It's a little bit. It's got some curve to it. Yeah. So you could use that in your reasoning. You could also use the fact that corrected itself to a straight line. It's supposed to be like this. You could also talk about this, first and second differences. That's a big part. That's the sort of stuff that we're looking for, like when we ask those questions. Okay. So we're kind of done with the lines, right? Because that's basically, I showed you the word problems, I showed you point of intersection, I showed you substitution, did all that stuff, right? Now we're going to move into this stuff. So obviously these are no longer lines. There's some curvature going here now, right? So these are quadratics. So what we're going to say here, we're just going to start with the basics and try to like get you to identify some of the points, okay? So from this picture, here's like, you're not going to be asked any more than this, okay? What's your vertex, axis of symmetry, optimal value, direction of opening, okay? Some are easier than others, okay? We could start with the direction of opening. What direction is that opening?
Down.
Down. Okay. Now,
we could also do the vertex.
Let's do the vertex. The vertex is very, 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 very informative. Okay, so it's just that's an important one, right? Where is the vertex?
It is -116.
Okay, so that would have been without you actually saying what the point was. It's the high or low point, right?
Okay,
that's okay. No, it's okay. Yeah. There's two, because you will see the optimal value is actually something, it's the vertex, but a specific piece of the vertex, okay? And I'll show you that in a sec. So you said the vertex, which is perfectly fine, -1 and 16.
Yeah.
Okay, and you always write it as a point, an x, y, right? Because that's what it is.
Yeah.
And then what about the axis? So let's do the optimal value next. Okay, you can do these in any order you want. Do you know what the optimal value is?
I don't think I did that.
Okay.
I don't. Well, I did, but I forgot it.
Let's say this. The way I kind of always remembered this was, let's say this is a graph representing money on the y-axis and like numbers of something sold on the x. Then the optimal value would be like the maximum amount of money you could make. Does that make sense?
Kind of, not really. Like how...
You can't tell negative of something. It doesn't make sense. Don't read the graph literally, but just like the y-axis is fine. So it's like if the graph was over here, the optimal value is going to be like how much money you could possibly make.
So it's just the highest point.
It's the highest point, but after some amount of like x value, right? So you're going to say the optimal value is a max, right? Because it's a maximum, right? Goes up, reaches the maximum, comes back down. That's why it's max. If it was the other way, it would be a minimum.
Oh, I remember that.
Okay, that's the optimal value. Max or min. And then you could get more specific by saying, okay, it's a maximum of 16 when x equals -1. That's like a perfect answer to a T. Like there's nothing else to say there. You could say, I don't know if your teacher's like looking explicitly for that. That's the way I kind of teach it, because then it means something, right? If you were over here, right, and we said the same, like let's say our graph looked like this, and we were selling something down here, then we would say a maximum of 14 after we sold 9 products. You see why I say it that way?
Because you have to kind of rely on the X.
Yeah, you're going to read the graph as is, right? But you're going to say, okay, well, I'm going to make a maximum of $1,400 after I sell 9 products. Or whatever, right? So I always write it like this for the reasoning of then I can actually put it into like a therefore statement or something afterward, right? And it means something, okay? So whether or not your teacher is looking for that much detail is aside from the fact, probably not actually, to be honest with you. You could probably just get away with saying max of 16. That would be perfectly fine, probably, okay? I just show you everything just because. Then zeros. Do you know where the zeros are?
Are the 2 points that intersect the
x-axis. Perfect. So one is at
-5, I think that is.
Yeah, okay. So these also are points, much like our vertex, right? So we got to write them as points. So what's the what's the y value at these 2 points?
0.
Okay, so we know we're going to have something that looks like this, right?
Yeah.
Something 0, okay? So then you said -5?
Yeah, and then the other one's 3.
That's perfect. Okay, what's the y-intercept?
Is that where the y-axis or y-axis?
Yeah, it's just like it's where it crosses the y-axis.
All right.
Right? Where's the graph cross the y-axis?
At 0 and 15.
Perfect. What I like the most is that you're telling me the point. Okay, because that's important.
Yeah, my grade 8 teacher is pretty strict on that.
Okay, good, because that's important. Like it's crazy the number of kids that go like that. I saw this tons, even in grade in the 3C, even the grade 11 college math, even some of the mixed math, they'll go like this for the zeros or x-intercepts. You can't write it. That's not. You can't do that, no, right? Because that's this. That's that point.
That's just not even.
It's not. Close. You know what I mean? That's not what we're doing. You know what I'm saying? So it's important. It's good you're doing that, because I see that a lot. This like kind of business here, the -5, 3. They combine the points.
Well, it's good I had a good grade 8 teacher for that, because he really got us prepared for high school.
Good.
So I'm fortunate, but I'll make sure to carry that through though, because that seems important for teachers. Because if a teacher's having a bad day, they could just be like, "Oh, that's wrong."
Yeah, it just depends. Yeah, and like the thing everybody's got to realize is when you go to sit down, try being a teacher like marking 30 of these. You know what I mean? 30 exams of like 10 pages. And it's like, okay, you can't. There's very little marking going on. Like there's no writing on the page or anything, right? Because you don't even get to keep them.
Yeah.
So when we go through that, it's like, it's pretty much black and white at that point, right? It's just like, okay, that's it. That's not it, right? Tests and summatives are a little bit different, but the final exam is like a different story, right?
Because you can't.
You just can't sit there and like try to figure out exactly what every kid kind of means. There has to be some like
line.
Line or like carbon copy or like a solution, right?
Yeah.
That just has to kind of be followed with some leniency, of course. But the last one, and maybe the hardest, is going to be this axis of symmetry. Do you know how to find this? Actually, it's not even hard. It's not even hard, actually. One bit, it's not hard.
I don't remember.
Okay, so the axis of symmetry is like, if you were to look at the graph, where could I draw a vertical line? Okay, I'll word it like this. Where can I draw a vertical line on here so that the graph is split perfectly into 2 equal halves? It
would just be where the vertex is, but it's going down.
Yeah, good. Right here.
Yeah.
Right there. Easy.
What would you put for a point there? The same as the vertex, or would you say it's like...
Okay. So you always say it has nothing to do with y, right? It's a vertical line. It's kind of independent of y. So the axis of symmetry, you're always going to just write as. Where did that come from?
The x, because it...
The x piece of the vertex.
Yeah.
And the optimal value came from the y piece.
So once you figure those out, can you just plug it in?
You just go like that. Boom, boom. Axis of symmetry is the x piece of the vertex. The optimal value talks about how high the graph went or how low the graph went. So you copy down the y piece of the vertex. Vertex is very important because it gives you lots of information about. You can answer lots of questions.
Because if you have the vertex and you can do the axis of symmetry, you can do the optimal value.
Yeah. You could even kind of, if you had the equation, you could kind of even know the direction of opening almost, right?
Yeah.
If you had one other point, you know what I mean? Like in this instance, I know these 2 points, right? I know the vertex and I know the Y-intercept. Those are two really, really easy ones. So because I know the vertex, I know that the graph's opening down because there's a point below the other one. You know what I mean?
Yeah.
I know it has to be symmetrical over here. I know it's opening down. You know what I mean?
Yeah.
You just gotta, like, the vertex is an important one because it'll tell you a whole bunch of stuff. Okay?
Alrighty.
Does that make sense?
Yeah.
Okay, so what I want you to do now, let's try and combine everything, okay?
Alright.
I want you to try and, like, graph this one. So you're on, like, I think you're on page 2 now.
Write this one down?
Yeah.
I should have been writing that.
That's okay. But I'll post this and then you got it. You can copy it all down later.
So we're on the second one here. Let's see if I can do this. That's
maybe one of the other reasons, right? Like, sometimes, like, teachers write, and kids are always, like, they're so concentrated on the writing and keeping up that, like, that's how I was. I was, like, completely blind to what was going on in front of me because I was so concentrated on writing down stuff and keeping up that I wasn't.
How I felt.
So that's what I mean.
Yeah.
So that is another reason why I do this, because kids can still sit here, do what you do, you're just finished doing. You can sit there and watch this, and, like, actually retain the information. You can watch it again later, and then now we can do a question. You know what I mean?
It's good prep for sure.
Yeah, like, it's always not everybody's gonna do this, right? Because this was quite a bit of money to get this all set up, right? So, and quite frankly, you got to be a bit tech savvy to work around some stuff, right? This isn't very common, but I think it's worth it.
Yeah, see, like, I'm not very techy. I know, like, for my generation, I should be, but
Yeah.
I'm not. I don't know. Like, this is all, like, I just find it pretty cool.
Yeah. I think there's some of that factor too, right? Where kids think this is cool. Like,
I like it. I mean, it helps for sure.
Yeah.
Because if I'm going home feeling like, I really didn't get that or something like that, I can go home and just be like, all right,
rewatch it. But you seem more like, if you had been writing the time, and this happens all the time when I tutor kids too, right? They're busy writing stuff as I'm doing questions. I don't think they're getting it at the same time. You know what I mean? It's like multitasking.
It's
some kids are good at it, some aren't.
I'm terrible.
Right? So, like, you seem way better and more receptive to watching the first time, and now I can guide you through something now. Right?
This is where I get to show what I've kind of retained.
Yes.
So that'd be negative times negative would be 2. Would that be right? 2 minus 4 for that first?
I'll do it right behind you.
Okay. So that wouldn't be minus 4. That'd be 6. How did I go? Oh, because that cancels it out. I don't know why I put 2. There, 4.
Yeah, squared, right?
And then I got that wrong too.
So you
I
added.
got only one of those wrong.
You added here. You gotta multiply. So it's that one is gonna be negative 4 multiplied by negative 2.
Oh, see, I saw that. I don't know.
You got the idea. Like, you went to it, right? And you know what to do. Now we just gotta like work on the mechanics of it.
Gotta follow it.
Yeah, but
okay.
Like I don't know. Sometimes like kids are like they look at that and I don't know what to do, right? But you jump to it, and we just made a math error, so that's fine. The math error is not the issue. It's like when kids look at it and they have zero clue what to do, right? It's like directing you that you added instead of multiply is way easier to fix than we just spent 15 minutes doing this and not knowing what to do. You know what I mean? That's way easier to fix.
Yeah, just little mistakes like that.
So that's all comes out of repetition. The more of these you do, like you're just gonna get better at the fact that like, oh, I need to multiply here, not that. You know what I mean? You'll just unwire whatever's going on in your head.
Yeah. See, I don't even know why. I saw a bracket and I thought multiplication, but I added it, so I don't know what really happened there, but that's okay. So yeah, that would be 8 plus 4. So that'd be 16.
Good.
So with this one, what helps with these equations up here too is you just can look at it and plug it in.
Yeah. I think this works the only thing I might add is there's not a lot of room in here. I kind of want to have a little bit more space for like what you're doing on the bottom to be able to do in the next box. You know what I mean? You know what I mean?
Like
it's just not the middle box, like the work area is not big enough.
Yeah.
You know what I mean? That's the only thing. I like this setup, right? Because you're right. We get to just kind of look at the equation, -1 squared. You're just following it.
And you just did put different numbers in for the axis.
Yeah. In different inputs, you get different outputs, right?
So that'd be 1. Oh, why am I writing it there? Okay, well, I'm going to have to do this one down here. I wrote the equation in that box. I'm just going to write that one down here.
That's fine.
But okay, so did I get that right? It's 1 plus 4. Oh, I did. Okay, sweet.
What's your answer?
9. No,
yeah.
Yeah.
There you go.
All right. And this one here.
And the 0 ones are easy, right? We'll learn this later. This might be the next page even. What happens when you plug... This is just like a line. What happens when you plug in 0 for x? 0 squared 0. 4 times 0. So except the last one.
Plus 4, so that's your answer.
Yeah. So let me stop you right there. Okay. What did we learn up here about... What's the x value along here? What's the x value here?
0, 0.
Yeah, the point would be 0, 0, but remember this is x and this is y. The x value along here is 0. What's the y value when x equals 0?
Oh, it's 15.
So it's the y-intercept, right? So what did you just find here?
The y-intercept.
Which is 4. So before you do anything, like you could do this whole table all you want, plot the points, and I think that's a good exercise. But identifying that is the y-intercept.
It's useful.
Yeah, it's you'll get the hang of like, oh, I know what this is because when I plug in x equals 0,
then you can find the vertex.
I get the y-intercept. You can find the vertex from these points too. Yeah,
because that's just 0, 4 if you're going.
Yeah, that's the y-intercept. So you got to find the. You said the y-intercept.
Yeah.
Oh, I was thinking you said vertex. Sorry.
Oh, did I?
No, I don't know.
Okay.
We could find out. We could do the replay on it and find out. I'm not sure. But anyway, there you go. Right? Because it's 0 squared minus 4 times 0 plus 4. So that's how
all that's 0, and then it's just plus 4.
Now the next one. What's interesting about here's where quadratics comes into play. Okay, this is why I like quadratics. You do the next one, and tell me if you see a pattern.
Alrighty. So I'm getting all confused now. No, I'm not. We're good. Okay. So -4 times 1, would that be just 4? Because you're multiplying a positive and negative?
Yeah.
Yeah. Okay. That's 9.
It is 9.
I'm guessing the other one will be 16, but let's find out.
Is it 9?
That's what I got, I think. Is it? Oh, it's 4.
What is it?
I thought it was 9.
Yeah, let's write it out. Let's write it out neatly. 9 was a good guess. Unless I'm doing something wrong here. The first one's 9. But what are we going to do? We're going to go 1 squared minus 4 times 1 plus
4.
Okay. So if we were to write that out down here, this is where so sometimes I even get tripped up in my head, right? Like I have an expectation that's supposed to be and it's not, because we have 1 minus 4 plus 4.
So that's completely different.
They're
it's
a wash.
0. Hard, it's 1. Because, oh wow, okay, I was really off.
So let's try the next one.
Okay. So, maybe 2.
Before we go any further, sometimes what I was expecting there is there should be some symmetry, as we talked about up here, around the vertex, right? There should be symmetry. We just haven't hit the vertex yet. Okay? So we're going to keep going down here. We haven't hit the vertex. That's our issue. Normally, we both assumed that this was gonna be the vertex, and there should have been some symmetry between the 9 and the 1 and then the 16 and the 16, right?
Yeah.
But we haven't hit the vertex yet. That's all that means. Okay? So we'll just keep going. Let's do the next one. So 2 squared minus 4 times 2 plus 4.
So 2 times 2 is 4, so it's 4 minus 8 plus 4. Is that correct?
Mm-hmm.
Okay, so that's 4 plus 4.
Remember what we can do? We can rearrange it too, right? So you could rearrange this and have negative 8 plus 4 plus 4, if you like. Or you can have it 4 plus 4 minus 8. You can rearrange this, right?
Yeah, so it's like easier. Yeah, so it's 0 then, because 4 plus 4.
Yeah.
So I thought.
Good. Okay. Now, what we need to do now is let's just check and see if this is quadratic or if it's linear. Because let's pretend I didn't show you this from the beginning and tell you that this was a squared and that means a quadratic. Let's just pretend I didn't tell you that. Let's go through the motions.
All right, so
okay. Let's do first and second differences.
So for do you have to go from bottom to top or top to bottom?
Let's try from top to bottom, see if we get a different answer. So 16 minus 9
is 7.
Okay. 9 minus 4.
5.
4 minus 1 is 3. 1 minus
0 is 1.
Yep.
Alright, and then we'll do second differences. So then the 7 minus 5 is 2, 5 minus 3 is 2, and then 3 minus 1 is 2. So yeah, that is quadratic.
Good. Easy, right? Now you know what to expect when you plot this, right? You expect it to be a bit curvy, not a line, because we just determined it was quadratic through the first and second differences. Okay, so let's just, what you're plotting is the inputs versus the outputs. Okay, so you're going to go negative 2, you're going to find negative 2 and 16. Right? And then you're going to go negative 1 and 9. And then 0 and 4. And then
1, 1.
1, 1. And then 2, 0, right?
I thought I did that wrong for a second.
Nope.
The 2, 0 there.
So, here's what you got, right? You've got this. Okay. I'll try to just connect it a bit better than I did. I have the luxury of doing it again. I still can't hit that dot.
That's one thing. How to make that look good on an exam.
I know. There we go. Okay. Now, I'm assuming, like, if we were to keep going here, let's just for fun's sake, and just so I'm not crazy, let's check what 3 would have done. Okay. If I plug in 3 squared minus 4 times 3 plus 4. What output should I get? Well, this is going to be 9 minus 12 plus 4. So 9 minus 12.
It should be 1 or negative 1 because is this not our... Is 2, 0... Oh, no, never mind. I'm thinking a completely different thing. All right, let's keep going.
Let's go. So 9 minus 12 is negative 3.
Negative 3, and then so it'd be 1. I was right. Okay.
So now we get to plot that point, right? 3, 1. So what does that make? What does that make this point?
That's our vertex.
Yeah.
And then after that, it just continues. It goes.
Yeah. How are you doing that? Why? Are you, how do you know that that is the thing?
Because after the vertex, that's like.
What is this?
Axis of symmetry.
Yeah, I'm gonna label this AOS. And how do I know that those points are valid? How far away, if this is an axis of symmetry, it has to be symmetrical, right? Like a mirror.
Yeah.
So this point here is how many boxes away from the axis of symmetry?
It's up 3 over 1.
Oh, okay, yes.
Oh, a box is away. It's one away.
Is it 1 or is it?
Oh,
1,
from
2.
that one. Sorry, I'm getting all confused now. It's 2.
2.
2.
So then I can count out 2. 1, 2.
And then there's your new point.
Same thing up here. 3 away. See how you can you just need half the graph to produce the other half, right? And now you got your whole parabola.
Alrighty, let me just plot that myself. So that's like our axis of symmetry right there. That's 3. That's 3.
So this was my test, okay? I did this without reading the question. Okay, so this doesn't really say anything, but my exam question might say, plot this parabola, and then label everything. So label your axis of symmetry, label your vertex, label your roots, x-intercepts or zeros if you have them. Like, just to label everything. That would be the only way I would extend that question, okay?
So let me just do that for fun because I didn't do it up here, so see if I can do this again. Do we have time for that? Or?
You can.
Okay.
It's up to you.
So
or we could do the next thing. It's up to you.
Okay.
It's all right there. I'll post it. I promise I'll post it this time. I'll post both of them.
Sounds good. Well, I'll do that later then.
Okay. So, here we have, this one will go quick. We have 2 forms of there's 3 in total, but for the 2P, you only do 2 of them, okay? The one we just finished seeing, okay, this one. Okay, that's just this with letters in it. Okay, instead of having a number where that is and a number there and a number there, it's just letters, okay? And they're letters because they could be any number. So but they're different, right? That's why it's A, and that's why it's B, and that's why it's C. Okay, so this one here is called standard form.
Oh, I remember this, but I don't remember how to, like, if it's all mixed up, you gotta, like, kind of get it into standard form.
Yeah, okay, I'll show you how to do that. That's like 4 and 5 today. Okay, so we're done. Yeah, okay, you have a good one there. Okay, so some of the information that can be found from this right away, okay, is the direction of opening. Okay, you can also find, which I showed you, what happens when x is 0 and these turn into zeros.
It's just,
what do you get?
C is your, oh, why can't I think of it now? Y-intercept. I was thinking axis of symmetry.
No, that's okay. That's the x piece of the vertex. Okay. And the last one, which you don't need to know, is like vertical. You don't need to know this. Okay, we'll just build it just because you'll need to know it in the 3C. You do, like, what's crazy about this is we spend so much time on this, and then in 3C we do it all again with a little bit more of a, like, there's a little bit more build to it. Okay, but you still go over everything again. Okay, so that'll be important in the 3C. Okay, this one, you know what this one might be called?
Oh, it's not standard form. I'm having a brain fart.
I don't expect you to know it. That's fine if you don't. That's why I put it down here.
All factored form. Okay, I remember that. My teacher said that a lot.
Yeah. This one's the most important, I would say.
All right.
Okay. Well, for the 2P course anyway. Okay, same idea here. You can't. Okay, this one's very close. You can still see the direction of opening. I didn't really explain how, but okay, you can tell that by looking at this value. Okay, do you remember if this is a positive, if it's negative,
it goes down or opens down.
Okay. You remember that?
Yeah.
And then the other one you can see is again the vertical. You don't need to know this. But the one you do need to know is the third one. And it's the x-intercepts / roots / zeros. I use all these words. Okay, I use all 4 of them. They all mean the same thing. Okay, x-intercepts, roots, zeros are solutions. Sometimes I just intermingle them, and I just put them all there just in case I do mix them around and say them in a sentence, right? And kids are all like confused. So those all mean the same thing. Do you know what those are?
Those are like like cross x-axis.
Yeah,
really?
right here.
So it's like those ones. Yeah.
All 4 of those words: solutions, roots, zeros, x-intercepts. All 4 of those. Okay. So
if you have, I guess does it cross it? If you have the second one here.
Good.
And there's no x-intercept or x-intercept. Yeah, it is.
This is a special case. This is a special case. There's only one. It crosses one square.
This is a vertex.
The vertex lies on the x-axis.
With 2, 0.
Yeah, that'd be your x-intercept, as well as your vertex.
So if they ever ask for that, I'd just be like, whatever's on the x-axis.
Yeah.
That's why I put
If there's 2 there, there's 2 there. And those are your solutions. If it's right there, then you just give them the vertex. That might be a trick question, right? What's your vertex? What's your x-intercept?
And
they're the same.
And because I think I got confused on that, because I'm like, there's no x-intercepts on this, but there is.
There is one.
Yeah.
It's touching in one spot. That's a good question.
All right.
I wouldn't do that in your course. That's a little bit of a low blow. Like, that doesn't, like, Obviously, you know from our discussion, I didn't teach you anything today, but you identified that those were the x-intercepts before I taught you anything, right? So why, I'm not here to trick you and ask you a question about that, right? Because did you get the opportunity to tell me or show me that you actually knew what they were?
Yeah.
With me, yes, but I just mean like in a test, if I put that on a test question, how many kids would I trick with this? You know? And then they're like, now I have the assumption that they don't know what they're talking about because I made a silly question. I mean, I just would do that. So then I asked the question here, like, which one of these forms is better than the other? This one doesn't tell me a lot. And it doesn't tell me a lot in the sense that I wouldn't be able to, aside from doing this process, I'm kind of stuck. You know what I mean? Like, I have to do this process to produce the graph. But there's a faster way. Right? And it's using, like, the more points that I can read directly from the equation, the faster I can produce the graph, right? You can see if I like had 3 points on here, I'd be able to do the graph really quickly. But because I had to use the table, it took longer, right?
Yeah.
So again, this gets back to like, do I want to use substitution as my fastest one? Or do I want to like plot the two graphs and figure, like, you know what I mean? I want to use substitution because it's fast. That's what we're doing with quadratics. I want to show you the method that's the fastest. Okay. So it turns out that like factored form is going to be better for producing the graph faster, okay? And we can see that here, okay? So this just, you got to flip your brain a little bit and go, okay, it doesn't seem like that, but there's a backwards way of thinking about this, okay? So all I want you to do is graph this parabola using this equation. Now, there's nothing wrong with, remember what I said, there's at the heart of basically all the math that you're ever going to do, you're going to be provided an equation. Doesn't matter how ugly or how easy the equation looks, you can always input values of x and get out y's. Right? You can always use a table, always. It just may not be the fastest way.
Yeah.
Right?
But I want to try and get to the fastest way.
You want to be, that's all the teachers are showing you is the fastest way to do this stuff. Okay? So, with things written in vertex form, you want to, what was one of the things I could answer up here? Direction of opening. Which way is this?
Is it also called vertex form? Because I know you see that.
Where did you see vertex form? I tried to get rid of that.
Oh, I thought you said vertex form.
Did I say vertex form?
I think so. Because I know there is.
There's a vertex form as well.
I forget what it looks like now.
Yeah. But. That one we don't do in the 2P. You do it in the 2D, and you'll do it in the 3C as well.
All right.
For entry purposes, it's not a lot different, but it's just another way to graph a parabola. Is all it is, right?
But that was another good one they wanted us to know when I did it.
Yeah. I mean, I don't think we didn't do it because I don't think it's actually in the 2P curriculum.
Yeah, that's okay though. That's good.
But you do it in the 3C for sure.
All right.
It opens a whole another can of worms for graphing parabolas, but it pivots around the idea that the vertex is very, very important. Okay. But with this one, remember that, look at the three things that we can see here, okay? Can you answer? All you want to do with these is like, can I answer some of these things right off the hop, right? And then just as you get one, it's like a Sudoku puzzle. You ever done one of those? Oh yeah. As you like get one, you can start. It starts unraveling itself. Yeah. As you fill out more of them, right? So let's start down here. What about the direction of opening?
I mean, do you use the -6 and -2?
Nope. Use, what's this guy here? Do you see that anywhere? No, it's supposed to be a number, but it's just 1. Remember, we can always just add a 1.
Which is positive, so then it would be, it opens up.
Good.
And then the zeros.
Okay, good.
I think, can you get those from that?
Yes, absolutely. That was the next step.
I mean, would it be -6, -2?
Okay, careful. Yes. Okay, right here. Okay. Here's like,
It can't be -2. Oh, yes, it could. It could.
Okay. Let me ask you a question. When you look at this graph, or any graph, and the x-intercepts are here, obviously, right? Because that's where they cross the x-axis. What's the y value here? Anywhere along that red line, what's the
0.
y value? Okay. So it's 0 equals. Now you remember back to our first session where we were trying to make left side equal right side? How do we do that?
You kind of have to rearrange it.
Rearrange it. So you can go, okay, well, x minus 6 equals 0, right? Or, so get me x by itself.
Well, it'd be x equals 0 minus 2. Oh, with both of them or just one?
You need to do both, but you can pick either one to start with.
So you could do x equals 0 plus 2. Because I said -2, but it's a positive.
So it's 0 plus 2, so x equals 2.
And then, so it'd be, that's your point right there, 2, 0.
Good.
Or 0, yeah.
Good.
And then the other one is, it would be 6 because it's just the same, just different number.
Okay, so long story short, without giving you the runaround like that, that's like what's actually happening. But when you do this is what I tell every kid. It's always opposite to the signs that you see here.
So if I have, say it's a positive 6 with a -2, would it be -6
Right.
positive 2?
Yeah. So
Okay.
if I'll do an equation in blue. Those are over here.
Because it's the opposite.
It's the opposite because you gotta flip it over to get x equals something. So you gotta have the opposite sign, right? When you go to make left side equal right side.
See, now that makes sense. If I go straight to that, I won't feel so bad about being a cut. I don't know how that works. Like, okay. That makes sense.
Now, this is an example of how things start to untie themselves, okay? I know your dad should be here in a minute, okay? So you said the two zeros or x-intercepts are 0, 2 and 0, 6. Okay? Now, what do we know about this? This is where I would go next. What is this?
Actually, once you get your points there, you can figure that out.
Yeah, you can. Where is it?
It would be 4. No, it wouldn't be 4. It'd be 0, 4.
Oh, okay. Yeah, no. It would just be 4. You'd write x equals 4. And you arrived at that because it's right in the middle of these 2 points, right? So here's your axis of symmetry. Oh, I'm over one. Okay. Now, I know I still can't do this. Okay. This is good now. There's one other thing, the vertex, and this might be the hardest thing for kids to just wrap their heads around, but I think you won't have any issue with this. This is an x value, right?
Mm-hmm.
What can I do with x values?
Plug it into a y value?
Plug it into x to get y.
That's what
there you go.
Yeah.
Okay,
so
let's
put it back into the equation.
And what are we going to get out? A y value, right? We're going to have a point to plot. So let's do that. Y equals 4 minus 6, 4 minus 2.
So that'd be y equals, well, if we carry all that down, it would be -2 times 2, which would be 4.
Yeah.
Would it be -4?
-4.
Because so if the negative comes before the positive, it's a negative, or if it's
So remember we said if you multiply two numbers and one of them's negative, the negative dominates.
dominates. Okay, that's
right. Doesn't matter the order. Multiplication doesn't matter. It doesn't matter if I wrote it like this.
You get the same answer.
And if you type that in, you're going to get -4 regardless. Okay. So -4. So which means your vertex, you plugged in 4, and what did you get out?
-4.
So you go plot that. It's right there. You can now basically graph the parabola.
Because now that's your vertex, and then
the
optimal value again is
optimal value is the y value of the vertex, and it's going to be a minimum this time, right? Because it's opening up, right?
Yeah.
And it's a minimum of whatever the y value is, because it goes down to -4. It doesn't go any below -4, right? So that's what the optimal value means.
Right.
It can't go any lower than that.
So min of -4, and the Y-intercept.
That's the last one we got to figure out, I think. Do you know how to do that? There's a shortcut. Like basically on what we have right now, you can't answer that.
Not right now, because there's no points crossing it yet.
But you have another method. It's the exact same method you just used.
Mind you, so would we plug the...
What could you plug in? Where's the Y-intercept? Right here. What's the X value along here?
0.
So plug in 0.
To this equation?
Yeah.
Okay. So it'd be -6 times -2, which would be 12.
Be way up here somewhere.
Yeah.
There you go.
So then it would be...
Now you know what your graph looks like.
12, 0 would be the... No, it wouldn't be. It'd be 0, 12.
Yes, good.
I get that backwards so many times. I know what I mean, but then I don't say it the right way.
As long as you write it down the right way. That's all that matters. Does that make sense?
Yeah.
Okay, good. So what we'll do next week, okay, I'll show you, and this is probably the hardest thing you're going to do in this course, okay? But I'll show you how to do this in an easy way, and you won't have any issues, I don't think, okay? But it all stems on, like this, all we're doing is getting you to switch between forms so that you can answer different questions that were up here. What's the Y-intercept? What's the maximum value? What's the vertex? That's all we're doing with this. They're all interconnected. You're just switching from factored form to standard form so that you can answer some of those questions. But the more important one, as you can see here, to produce this graph, is to switch from, what form did we have? Factored, right? But if we want to get to factored, that must mean I'm going to be given standard. So I'm going to switch from standard into factored so that I can produce graphs so that I can answer all these different questions, right?
So that's next week, because from factored form, you can find it a lot more than looking at it like that.
Everything you just answered here came from that's factored form. Right? Look at all the information you just found from here.
And you didn't even need to really do much work, just plugging it in.
So the work is in taking it from standard form and switching it into factored form so that you can answer all that stuff. That's like it's not hard. It's the hardest thing you'll do in this course. But kids just don't understand why they're doing it. They don't understand the process. I'll show you all of it. You understand the process and why we're doing it. Then it'll make sense.
I just got to get familiar with it, and then I'll be golden.
It's just honestly I'll show you 4 of them, and it'll be I'll do 2, you do 1, and then I'll do the last one or something, whatever we decide on doing. But if you do I don't know, you did 20 of these things, you'd never make another mistake again. It's just
a repetition and trying to follow the same process, even if you don't. I look down there's no Y in one of them. It didn't look like I said.
Oh yeah. So that might have been me typing it wrong, but that doesn't matter.
Oh, okay.
You can always put the Y up front. That's always equal to Y. Right? That doesn't matter.
It doesn't matter if it's behind.
It has to be equal to something.
Yeah.
Is you okay with that?
Yes.
Okay, so we'll do that next week. You seem okay, with this. This is not easy. This wasn't necessarily the easiest thing in the course.
I don't think I did terrible with quadratics. There are a few things I definitely missed, but for the most part, I found that was one of my better units.
Okay.
It was the only one I passed of all of
them. Okay, so maybe we'll rip through this, and then we'll do some trig or something.
And trig, I forget if I was using the trig or not. It's a cosine.
Cosine, sine, cosine. So
yeah.
sine, cos. You won't do tangent. You'll just do sine and cosine.
Okay, because I did tangent too. When I was.
Oh, you will do tangent. Sorry, you will.
No, okay. So there's 3 of them.
There's 3 of them.
Sine,
but
cosine.
You'll use it. That's like a real life thing, right? Like you'll use that everywhere.
Like business kind of stuff.
Not so much like business math, but like what your dad does. Like trig is everywhere. You start landscaping stuff and all trig. Building ramps, like making sure something's square. Like if you have 2 pieces of wood, you want to make sure they're square. How long do you you know what I mean?
Yeah,
it's all trig. Or 2 different lengths of wood, and you want to make sure that they meet square. Trig. We'll do that. That's an important one.